Okay, so for this question, we have C3H8 plus 5O2 creates 3 CO2 plus 4 H2O. We have 2 grams of O2, 40 grams of C3H8, and we're trying to figure out how many grams of CO2. So an important concept for this is going to be understanding how limiting reactants work. Now, in order to demonstrate how these work, I'm going to use the analogy of a Coke bottle. Okay, so let's say in order to make Coke, you need 1 ounce of syrup and 10 ounces of water. How many Coke bottles could you make if you have 3 ounces of syrup and 40 ounces of water? Well, this is pretty obvious. If you need 1 ounce of syrup, you can make 3 bottles because you have 3 ounces, and you will have 10 ounces of leftover water. So this is basically the same concept, but with limiting reactants. One of them will run out before the other, stopping the reaction, and will have an excess amount of the other one. So in order to do this, you're going to have to understand how mole conversions work and how mole ratios work. I'll link videos in the description if you need some help with that. But first, we're going to find the limiting reactant, the reactant that will limit how much we can make. So in order to do this, we have 2 grams of O2. So we'll just put that there, 2 grams divided by the atomic weight of O2, which is going to be 15.999 times 2, because again, 2 of them. And we're going to multiply that by the mole ratio. So we see here there is 3 of CO2 and 5 of O2. To be 3 over 5. And then we can convert this to grams. We are trying to find the amount of grams of CO2. So this here, we'll convert it to moles of CO2. This again being the mole ratio, this being the moles of oxygen. So in order to convert the moles of CO2 to grams of CO2, we are going to multiply it by the atomic weight. So carbon is going to be 12.011 plus 2 oxygens. So again, 15.999 times 2. Now, if we put this whole equation into Desmos, or again, any other calculator, here we have the equation. We can see it's 1.65 grams of CO2. Let's put this here to the side that this creates 1.65 grams CO2. And now we're going to do the exact same process, but for C3H3. So we have 40 grams divided by 12.011 times 3 plus 1.008 times 8. Again, this being the atomic mass of carbon, this being the atomic mass of hydrogen, times the amount of atoms that are in there. This is going to give us the moles of C3H3 times the mole ratio. Again, 3, and there's an implied 1 here. So let's put that there. So 3 on top, 1 on bottom. Again, this will be moles of CO2 that this generates. So again, multiply this by 12.011 plus 15.9992. And if you're wondering where I'm getting these numbers, these are just the atomic mass. So we go here, the carbon 12.011, oxygen 15.999. Yet again, we're just going to plug this into Desmos real quick. So you can see here, I copy the equation in and we get 119.7 grams of CO2. So we can see here that it'll stop at 1.65 grams of CO2 because it'll run out of oxygen. 1.65 grams of CO2. But what if it's asking how much excess reactant you have left? The way you would do that is to take the 1.65 grams of CO2. So we'll get 1.65 grams. Divide this by the atomic mass, again, just converting it to moles, multiplying it by the mole ratio back to the excess reactant. So in that case, it'd be 1 over 3. And again, convert to grams. See if I can fit this in here. 12.011 times 3 plus 1.008 times 8. So let's just put this to Desmos. So that means it'll consume roughly 0.55 grams of C3H3. So if it's using this amount, then all we have to do is do the starting amount minus that amount. And again, I've just assigned this to a variable to get a more accurate answer. So 40 minus A is 39.44. So we'd have about 39.44 grams of excess C3H3. So I hope this helped. Leave comments if you have any comments or concerns.